Welcome, everybody. This is reducing methane emissions from solid waste sector. Both California and China participating. Thank you all for being here. It's my pleasure to be here. My name is Ken Alex. I'm part of the Center for Law, Energy, and Environment here in windy and rainy Berkeley, California. Before we begin, first let me say thanks to the California-China Climate Institute here at Berkeley. And I want to mention a couple of housekeeping things to note, one of which is in the chat right now. This event is being simultaneously translated into Mandarin Chinese. Please select the language you would like to hear using the globe icon at the base of your screen. You can choose English or Chinese, but please choose one so that you're no longer in the off position. I'll give you just a second to do that. Okay, this discussion is being recorded and it'll be available soon on the California-China Climate Institute website and on our YouTube channel. So throughout today's discussion, if you'd like to direct any questions to our panelists, please use the Q&A function, which is also at the base of your screen at any time, and we'll do our best to answer as many of them as we can during this session. Very exciting session today. I'll get to the introductions of our great group of speakers in just a minute, but let me just mention a couple of basic methane and land use facts to set the stage. The solid waste landfill sector accounts for about 20% of global methane emissions. And in fact, many of the super emitter sites, the biggest sources of individual methane emission, are from the landfill sector around the world. Methane is the third largest source of anthropogenic methane emissions in the United States, behind the agriculture sector and oil and gas. Total generation of municipal solid waste is estimated to increase by something like 70% by the year 2050, primarily as the result of population growth. The increase in waste generation has the potential to drive a proportionate increase of landfill gas, primarily methane and CO2, the two greatest contributors to global warming. As the two largest economies, China and the US, but California and China are now taking action to reduce methane emissions from the solid waste sector. California and China are pursuing some different policies and technologies and adopting them. And so the two jurisdictions have lessons that they can learn and teach each other and experience that they can share. Today, the California-China Climate Institute is introducing its latest report, Reducing Methane Emissions from the Solid Waste Sector, Lessons from California's Experience. And we'll have a discussion in a minute of that new report. We also have the honor of having several issue experts with us today to provide valuable insights and information on how both California and China can reduce solid waste methane emissions. So thank you all for joining us. I'm going to introduce all of our speakers. So I'm going to run through. We have 7 speakers that I'll give the short bio before we turn it over to the speakers. The first person you'll hear from with some opening remarks is Dr. Zhang Lin. He's the Nat Simons Presidential Chair in China Energy Policy at Lawrence Berkeley National Lab, a staff scientist at its Department of Electricity, Market and Policy, and an adjunct professor at the Department of Agriculture and Resource Economics at the University of California, Berkeley. Dr. Lin's research is focused on energy and climate policy, energy and emission pathways, with a focus on non-CO2 greenhouse gases, electricity market and planning, low carbon economic transition, and appliance efficiency issues in China. Next, we'll hear from Rishan Xu, who will give a detailed discussion of the report that is being issued today. Rishan is a methane policy fellow at the California China Climate Institute. He's worked on a broad range of environmental issues such as methane control in China, air pollution, and corporate and social responsibilities. His areas of interest are methane emission reduction, China's decarbonization path, and the function of policy design in promoting sustainable economic development. Then we'll have a panel of three folks. The first will be Matt Harrison. He's the manager of short-lived climate pollutant policy for the California Air Resources Board. Matt brings his experience in sustainability and public interest work to address complex challenges around greenhouse gas mitigation, climate adaptation, ecosystem stewardship, and resource use efficiency. We'll also hear from Kara Morgan, who has worked for Cal Recycle since 1991, the state agency in charge of waste management. Prior to that, Kara worked for the Division of Recycling, and she is the branch chief at Cal Recycle. We'll hear from Dr. Liu Xiao, project manager of Rethinking Plastic Circular Economic Solutions to Marine Litter in China, and Integrated Waste Management NAMA project. He is also a member of Recycling and Waste Minimization Committee and has more than 15 years of experience on municipal solid waste management and sustainable development. He mainly focuses on integrated waste management and low carbon transition, plastic waste management, and pollution control. And our closing remarks will be from Dr. Shuo Zhang, the chief scientist and senior fellow of the Lushu Institute of Ecology and Environment at Nanjing University. Shuo received her PhD from Emmett Oh, you know what? She's part of the panel. I misstated that. Sorry about that. She's received her PhD from Emmett Interdisciplinary Program in Environment Resources at Stanford University. Her area of research interest is decentralized waste management, environmental governance, and environmental climate and policy. The closing remarks will be delivered by Min Chen, who's the program director and senior analyst at the Innovative Green Development Program. Her research focuses on climate change policy analysis and data development, carbon markets, and non-CO2 greenhouse gas emissions. Mian holds a PhD in political science from the University of Oregon. And with that great set of folks, let me turn it over to Dr. Lin.
Well, thank you, Ken, for that nice introduction. Welcome to everyone online to the launching event for our joint report on methane mitigation opportunity experience in California. As many of you probably know, methane is a short-lived greenhouse gas with more than 80 times of the warming impact of CO2 in over 20 years. Reducing methane emission is considered critical in limiting temperature rise in the near term. Globally, 150 countries have joined the Global Methane Pledge with a goal of reducing 30% of global methane emissions by 2030, which could reduce warming by 0.2 degrees Celsius by mid-century. So that's quite a bit. The US and China have affirmed their commitment to reducing methane emissions in their joint Glasgow Declaration on Enhanced Climate Action. Waste is about 20% of methane emission in both countries after agriculture and energy. For energy and agriculture, the relative contribution of methane emission is quite different between the US and China. For example, in the US, oil and gas is the majority of methane emission in the energy sector, while in China, coal mine methane is the leading source of emission. In comparison, there's a fair amount of similarity in the waste sector methane emissions, both in terms of sources and the mitigation measure, as well as governance structure. For example, while national governments set overall mitigation goals, it is the local government that implements the program. In the US, for example, there is a national goal of 70% reduction in all landfill methane emissions, but the federal government leaves the primary responsibility to state and municipal government to design and implement their own programs. In China, there is a zero waste city program that's piloting waste and methane reduction in selected cities, such as Suzhou. California established a first in the nation methane emission reduction target, 40% reduction by 2030, and has conducted many policies and programs to reach this target. We thought the experience and lessons learned in California could be informative to our colleagues in other subnational jurisdictions as they design and implement their own programs. That's why CCCI and the LBL teams decided to work together on this report. In addition to this report, I also want to mention we have another report on what China and the US could do in their own national actions and collaborate in the methane reduction as well. That report is also available on CCCI's website. Now I'm going to turn over to Rasheen to introduce our report.
Can you see the slides? Just to confirm.
Yes.
Okay, yeah. Yeah, thanks, Jiang, for the introduction. Hello, everyone. Today, I'm Rixin Zhu from the California China Climate Institute. Today, it's my pleasure to introduce our latest report from CCCI, which is reducing methane emissions from the solid waste sector, lessons from California's experiences. This report will analyze the policies in California related to solid waste methane, and will give 5 policy recommendations that can be applied to other regions around the world. So first of all, just some background information about why we should focus on methane and why we should focus on solid waste sector. As Jiang just mentioned, methane is a very powerful greenhouse gases, 80 times as potent as carbon dioxide and trapping heat. And also methane accounts for 20% of global greenhouse gases emissions. Reducing methane could avoid nearly 0.3 Celsius degrees of global warming by the 2040s. So that's why we focus on methane. And the reason we focus on solid waste sector is because in California, the solid waste sector accounts for 22% of the state's methane emissions, which is a lot. So that's why this report focuses on solid waste methane. To start off, this report has done research in 2 major solid waste methane reduction strategies in California, which is diverting organic waste from landfills and reducing methane emissions from existing landfills. So for diverting organic waste from landfills, we did this research because most of California's methane comes from organic waste, because organic waste will decompose in landfills through biological process. By diverting organic waste from landfills, we can prevent methane generation in the first place. And the second strategy is reducing methane emission from existing landfills. We focus on this is because existing solid waste landfills will emit methane for decades, and it is important for California to collect and utilize landfill methane for multiple purposes, such as heating and electricity generation. So let's talk about the first strategy is diverting organic waste from landfills. So California has a series of policies that is related to diverting organic waste from landfills. So the first type of policies is standards and regulations. California has already established a statewide mandatory organic waste recycling program. And in 2016, California released the Senate Bill 1383, which sets ambitious goals for organic waste disposal reduction and food recovery. Besides standards and regulation, California also released many financial incentives to encourage organic waste diversion from landfills. For example, the California government has set procurement targets for landfill methane and organic waste products for each cities and counties in California. California has also taken actions to encourage organic waste products market expansion to increase the demand of such products and to encourage infrastructure expansion. California also collects integrated waste management fees from landfills, which and this fees is the major financial sources of the California Department of Resource Recycling and Recovery. So these are the major policies that California has adopted to divert organic waste from landfills. Okay, so I would like to talk something about the progress that California has achieved by far. So California has achieved 42% of solid waste recycling rate in 2020, and the organic waste disposal amount has decreased by 11% between 2014 and 2021. Both of this progress lags behind what is required to do by the California government. But one major reason for this is because the regulation under the Senate Bill 1383 are prohibited from taking effect until January 2022, which means after those regulations take effect, the situation would likely to improve. Just now I talked a little bit about the overall progress in California, and I will also talk some details about organic waste processing infrastructure, because these types of infrastructure is very important for organic waste diversion. So in California, organic waste processing capacity has increased by more than 400,000 tons in the past few years. And by 2020, California has paid roughly $140 million to help local governments construct organic waste infrastructure. However, although California has already invested a lot, the organic waste processing capacity is still not enough to achieve the 75% organic waste disposal reduction goal by 2025. And as you can see in the graphs at the right-hand side, the blue bar is the anticipated capacity in 2025, and the gray bar is the necessary capacity in 2025. And there is a huge difference between these two bars. Which means California still needs more organic waste processing infrastructure in the future. And California has also taken actions to expand the markets for recovered organic waste products. There are two major types of products in California, and there are compost and biomethane. For compost, situation are good because the market and demand for compost are currently strong and mature. For biomethane, things are more complicated because markets for biomethane as renewable natural gas for use in vehicles is currently strong, but the markets for biomethane as a heating or electricity sources are relatively weak due to issues such as high capital costs and market uncertainties. So these are the progress that California has made in diverting organic waste from landfills. So what are the challenges? Basically, there are three major challenges that California is now facing. First of all, there's a slow progress of establishing waste collection and recycling services. And second, there's still a lack of organic waste processing infrastructure in California, as I just mentioned before. Finally, organic waste product market expansion also faced some challenges. For compost, there is still accessibility issues because some customers in California don't have access to high quality compost. And for biomethane, there are still barriers such as market uncertainty and high capital costs that prevents biomethane to be, that prevent the demand for biomethane to be increased significantly. So these are all about the first strategies, diverting organic waste from landfills. And next, I would like to switch my gears to the second strategies that this report focused on, reducing methane emissions from existing landfills. So similar to organic waste diversion I just talked about, California also have many policies to reduce methane emissions from existing landfills. For example, California has many standards and regulations. In 2006, California released the Assembly Bill 32, requiring California to reduce its greenhouse gases emission to 1990 levels by 2020. In 2010, California released the landfill methane regulation, which is the current regulation and is also the first regulation for landfill methane control in the United States of America. Besides standards and regulations, California also have many financial incentives. For example, some California State Department, such as the Department of Resource Recycling and Recovery, has provide financial support to landfill gas recovery projects across the states. And California also provides equipment loan program to support local enforcement agencies in California. Finally, California has also conducted landfill methane quantification through model estimation and through a statewide methane hotspot research. And similarly, let's talk about the progress. So in California, the landfill methane emissions has been increasing since 2010, according to the latest greenhouse gases inventory published by the California Air Resource Board. However, there are still good things. For example, landfill methane emission per ton of municipal solid waste show a decreasing trend in the past 10 years. So as you can see in the graph at the right-hand side, the green line stands for the methane emission per ton of municipal solid waste in landfills, and there is a decreasing trend in this line. So this is very good, especially considering the increasing tonnage of municipal solid waste in landfills nowadays. So one of the major reasons for this decreasing trend is because there is a significant proportion of landfills in California that have installed landfill gas collection and control system. So by installing this type of system, the methane from landfills can be collected and utilized for multiple purposes instead of being emitted directly to the atmosphere. Okay, but there are still many challenges in reducing methane emissions from existing landfills in California. One major challenge is the scarcity of landfill methane emission data, because there is currently no continuous methane linkage monitoring, and sometimes landfill methane monitoring could cost a lot. Although California has conducted methane hotspot research, but this type of research can only provide snapshots. Also, the model that California used to estimate landfill methane emission has some sort of inaccuracy in itself, and some new models have not been incorporated into landfill methane inventory by far. Finally, there is not much technology improvement for landfills in the past decades, especially in terms of reducing landfill methane control. Yeah. So now I have I did a brief introduction to the two major strategies that this report focused on, and now I would like to give you some conclusions and some final policy recommendation that comes out of this report. So first of all, there are absolutely many best practices in California that could be applied to other regions in the world. For organic waste diversion, California's mandatory recycling programs could be very efficient, and also the financial support for infrastructure expansion and market expansion program in California significantly encourage the organic waste diversion from landfills. And for landfill methane control, California released its landfill methane regulation in 2010 as an early response to the Assembly Bill 32, which is really important and which is very efficient in control landfill methane emission. And also California has provided many financial support, such as grants, research funding, and equipment loan to support local government to control methane from existing landfills. So these are all the best practices in California. There are also challenges, by the way. As I mentioned before, the progress of establishing waste collection and recycling services in California is still a little bit slow. But I believe that things will change after the Senate Bill 1383 take effect last year. Yeah, so there are also a lack of waste processing infrastructure as well as barriers to organic waste products market expansion. So these first three challenges are for diverting organic waste from landfills, and for control methane from existing landfills. There are still a scarcity of landfill methane emission data, and there are still some inaccuracy in the landfill methane emission model that California is using now to estimate landfill methane emission. Finally, I would like to give 5 major policy recommendations that comes out of our report. So the first one is about the content of a appropriate methane policy package. We think that a comprehensive methane policy package should include policy regulation, financial incentives, and behavioral change focused programs. Second, organic waste recycling and edible food recovery are very critical components of solid waste methane mitigation strategies, because these methods could significantly lower the cost of organic waste processing. Third, more infrastructure capacity is necessary to divert waste from landfills. And for subnational governments, it is also very important to consider and address the negative impacts of some organic waste treatment options, such as composting and anaerobic digestions. For landfill methane control, it is important to have advanced monitoring system, accurate inventory models, and financial support for technology innovation. And finally, accountability is important, because given the role of municipalities in waste management in many subnational jurisdictions, enforcing local compliance with state or national regulation is essential to implement methane reduction strategies. So these are the 5 major policy recommendations from our report. And I think that is the end of my brief introduction to this report. If you are interested in this report, you can read it through at the CCCI website. And I think that's it. Thank you very much.
Great. Thanks, Rishan. Really excellent description of very thorough report on California's waste sector. And now for some more detail about that and what California is doing, let me turn it over to Matt Harrison of CARB.
Great. Can you guys see my screen?
Yes.
Cool. Thanks. All right. I am Matt Harrison. I manage the short-lived climate pollutant policy section at the California Air Resources Board, or CARB. And I am going to give a very short overview of the state's policy and statutory framework for addressing climate change, and particularly methane emissions from the waste sector, and also touch on how CARB's programs are advancing those efforts. All right, so beginning in 2006, with the passage of AB 32, California's legislature tasked CARB with reducing greenhouse gas emissions to 1990 levels by 2020. In 2016, this mandate was strengthened and extended to require a 40% reduction to 1990 levels by 2030. Also in 2016, the legislature passed several bills specifically addressing short-lived climate pollutants, or SLCPs. These directed CARB to develop a plan to reduce SLCP emissions and to adopt and begin implementing that plan, called the SLCP Reduction Strategy, by January 1, 2018. In addition, the 2016 legislation requires methane emission reductions of 40% below 2013 levels by 2030. And it also required a specific sub-target for the waste sector to reduce the disposal of organic waste in landfills by 50% in 2025 and 75% in 2030. Most recently, in 2022, AB 1205 established the policy of the state to achieve carbon neutrality no later than 2045, to maintain net negative GHG emissions thereafter, and to ensure that by 2045, statewide anthropogenic emissions are 85% below 1990 levels. Methane at landfills in California predominantly comes from the decomposition of organic wastes that already exist in those landfills, and organic waste makes up over half of the landfilled waste stream. Landfills are the second largest contributor to the statewide methane inventory, making up over 20% of methane emissions in the state, or about 8 million metric tons of CO2e annually. And this is all in spite of the fact that 95% of the waste that's disposed of in California landfills is deposited in landfills that are equipped with the gas collection and control systems. And so while we know that these systems are designed to capture landfill gas that's generated each day as waste decomposes, we also know that a portion of that gas escapes to the atmosphere of methane. So the state's implementing several initiatives to support action on reducing methane from organic waste. CalRecycle is implementing both regulations and incentive programs that are designed to ensure that organic material is directed to its highest and best use. And my colleague from CalRecycle will cover that in more detail in a minute. CARB also administers 2 programs that help support methane capture and use to meet the state's emission reductions target. The first is our landfill methane regulation, which has been in place since 2010 and is our primary mechanism for controlling emissions from waste in place. The regulation established the most stringent threshold in the nation for landfills to install control systems, and also includes a comprehensive set of monitoring provisions that are intended to reduce methane emissions. This set of practices that's required under the regulation is estimated to capture about 75% of landfill gas and reduce emissions by nearly 2 million metric tons of CO2 annually. However, landfill emissions are highly variable, both seasonally and spatially within and among landfills. So it's really difficult to quantify facility level emissions, and that's not something we do through this regulation. CARB's second program is the Low Carbon Fuel Standard, or LCFS program, which credits biomethane generated by diverting organic waste from landfills. When organic waste is sent to an anaerobic digestion facility, degradation of that waste can be controlled, which allows the methane to be captured and used more efficiently compared to a landfill. Biomethane can receive LCFS crediting through either pipeline injection, direct use on site in vehicles, or by generating electricity. To date, the LCFS has provided over $4 million in incentives for waste diversion projects. The 2022 scoping plan update, or the state's overarching plan to achieve our climate target, lays out a path to achieve carbon neutrality and reduce anthropogenic greenhouse gas emissions by 85% below 1990 levels no later than 2045. This is taken from the waste sector analysis, which identified that reducing organic waste disposal, which is shown in the yellow dashed line, is the most important action we can take for achieving long-term methane emissions reductions. CARB staff also estimate that direct emissions reductions of 10%, roughly 10%, is achievable across the state's landfills by 2030 through a combination of improvements in use of lower permeability covers and advanced landfill gas collection systems, as well as through advanced monitoring to detect leaks and repairs, including through wider adoption of remote sensing technologies. So this figure shows that while organic diversion is the most important mitigation measure, improved control measures can also play an important role to help reduce emissions to 2013 levels much faster than through diversion efforts alone. And this sort of emphasizes that last point and shows the importance of addressing emissions from waste that's already in place at landfills. The remaining degradable carbon, which is shown here in blue, is the amount of waste with potential to generate methane that has been deposited in landfills over time and is not yet broken down. This quantity is constantly in flux. It increases on a daily basis, or it can increase on a daily basis as new waste is deposited into the landfill, or it can decrease as a fraction of the carbon biodegrades and is converted into carbon dioxide and methane. As the figure shows, the amount of carbon remaining in landfills contributes to methane emissions in 2019 was over 20 times larger than the amount added in that year. So this illustrates the fact that the key takeaway from this slide is that even if we were able to entirely fill out landfilling of organic waste today, existing waste in place at landfills would continue to generate methane for decades into the future. So I'll wrap up here with an overview of the state's key strategies to address methane emissions from the waste sector. To minimize emissions, we need to divert as much new waste as possible to advance both our greenhouse gas targets and a variety of other statewide objectives. This is much easier said than done. It's a huge lift. Again, my colleague from CalRecycle will talk more about this, but involves coordinating at a state level with jurisdictions, municipalities throughout the state. In addition to greenhouse gas emission reductions, it will deliver a variety of other co-benefits, including food recovery that could be used to combat hunger in communities statewide. We can also recycle the remaining inedible materials into compost, fuel, and other products, and in doing so can potentially avoid an additional 4 million metric tons of CO2e annually by 2030. And we also know that these strategies support jobs and produce useful products in the state like compost, which has demonstrated benefits for soil health and food security. On the gas capture side, methane from waste already deposited in landfills, as I mentioned, includes new technologies and management practices that minimize emissions from waste that's already in place. And on the monitoring side, CARB is engaged in an innovative work using satellites to map methane emission sources in California. Through the California Satellite Partnership, CARB has demonstrated the importance of this technology for leak detection and repair and is on track to launch 2 satellites in 2023. This will enable quicker detection and visualization of high-emitting methane sources with the ultimate goal of launching a constellation of satellites that can provide regular, complete, precise, and timely measurement of methane. So again, that's a summary of the state's key strategies, and we expect that a combination of those efforts will help us achieve the aggressive climate targets that I just described. And that is it for my remarks. Thank you.
Thanks, Matt. I think you underscored some of the complexity of this issue. And I also want to note that this is both the within the jurisdiction of the Air Board and of our next speaker's agency, CalRecycle, that it's a multidimensional problem. So Kara Morgan, over to you.
Thank you so much. I am so happy to be here, and particularly I'm happy to be here to report on California's progress. Next slide. As Matt shared, Senate Bill 1383 is part of California's larger strategy to fight climate change. In California and across the world, we're already experiencing the devastating impacts of climate change. And we believe that implementing this regulation is a fast track to battling climate change. Next slide. I just wanted to speak briefly about what organic waste is as it relates to this regulation. It includes anything that's organic that's disposed in landfills that emits methane. So when we talk about organic waste, we're not talking about just food waste and green waste. We're talking about paper, textiles, lumber, wood, biosolids, digestate, manure, and other types of sludges. In January 1, 2022, the regulation took effect. Across the state, jurisdictions, industry, nonprofits, us at CalRecycle has been working really hard to implement this regulation, and I'll tell you about some of that progress. On January 1st, 2024, jurisdictions will be required to take enforcement against non-compliant entities, and I'll share a little bit more about that. Next slide. So SB 1383 in this regulation is a statewide target. It is not a jurisdiction organic waste diversion target. And due to this structure, our regulations establish state minimum standards. So we set these standards, the types of programs and activities that jurisdictions must implement and that our processing facilities must also adhere to. Jurisdictions and the regulated community have to demonstrate compliance with each of these standards. And on this slide, it shows the main requirements that jurisdictions have. Next slide. So there are so many benefits if we can successfully implement California's super pollutant reduction strategy. California has been working with our cities and counties and other partners in the industry to implement this very aggressive goal. In doing so, we've developed a regulation that provides a lot of flexibility as well as various pathways for compliance. On my team, I have local assistance staff assigned to every jurisdiction. They're meeting regularly with these jurisdictions to provide them assistance and guidance in implementing these requirements, because our goal is for every jurisdiction to be in compliance with the requirements. We've developed many different tools and resources, from training webinars, many education outreach materials, presentations to elected officials, model tools to support capacity planning, facility measurement, edible food programs, and procurement. Next slide, please. Our governor and our state legislature has really invested in building the circular economy in California. As part of the governor's $15 billion climate package in last year's budget, CalRecycle was provided $270 million in funding to advance our circular economy. And on this slide, you can see some of the money and what we've used it for. This year's funding, we have $180 million to provide local assistance grants to our cities and counties and special districts that provide solid waste collection services, as well as $10 million for co-digestion at wastewater treatment plants. This year, we are implementing our 7th cycle for our organic facility grants. This cycle, we have over $150 million that will be available for these grants. So, you know, as we talked about earlier, one of the challenges is building out the infrastructure in California for our programs. And we are already seeing significant expansion of organic waste recycling infrastructure in California. And we expect with this next grant cycle to see even more either new facilities or expansion of existing facilities. Additionally, with the millions of dollars that we have expended in really focused on the edible food recovery infrastructure, we are seeing that that infrastructure is expanding leaps and bounds across California. And that goal of hitting 20% of edible food recovery for human consumption, you know, that is a realistic goal that we can achieve and hopefully surpass, and have, you know, experiencing many benefits. Next slide, please. So there are various pathways for local compliance with the 1383 regulatory requirements that took effect in 2022. The regulations allow for various curbside collection programs, and that includes, for many of our jurisdictions, they already offered residents and businesses 3 containers. Now those residents and businesses can put food waste and food sold paper into those green waste containers that they already had. So that's provided a lot of flexibility, some cost savings there. Some of our requirements include having specified container colors. You know, we're all familiar, at least in the US, with red, green, and yellow stoplights. Well, similarly, we are moving forward and phasing in colors for our containers. And by 2036, all of our containers will be color compliant: green for organic waste, blue for recycling, including fibers, and gray or black for basically the trash containers. As I mentioned, this flexibility includes certain types of waivers and exemptions. So for some of our jurisdictions that are more rural, have lower population or high elevation, way up in the mountains, they have certain waivers so they're freed from some of the collection requirements, again, providing them flexibility. Also in 2021, lawmakers passed another piece of legislation called SB 619 that gave local jurisdictions the opportunity to submit to the department a notification of intent to comply, basically acknowledging that they had violations and that they put forward a plan with a timeline to correct those violations. We are currently reviewing and working on 127 jurisdictions that have approved notifications and putting them on corrective action plans to monitor their progress. Next slide. CalRecycle has overall the oversight over jurisdictions and federal facilities, state agencies, school districts. As we built this program, today we have 618 cities, counties, and special districts that provide solid waste collection. I am happy to report that 445 of those jurisdictions have already implemented residential collection services. More than half of the jurisdictions, well over half of the jurisdictions, have commercial collection programs. And that number is important because as I just mentioned, a number of jurisdictions have waivers and relief. And that equates to about 139 jurisdictions that have approved waivers. Add that number to the 127 jurisdictions that have those SB 619 notifications, giving them more time for implementation. And across the state, our jurisdictions with all of that are really moving forward. We're really seeing huge progress since at the beginning of 2022. Jurisdictions had their first reports to CalRecycle. That took place this past October. We also have received and are analyzing the capacity planning reports. Those capacity planning reports identify those jurisdictions that don't yet have enough either identified, expanded, or new capacity. And they will have to submit to CalRecycle a plan as to how they will build that capacity. But overall, across the state, at least for these next few years, we are seeing a good amount of capacity, either existing, being expanded, or new capacity coming online, both for organic waste recycling as well as edible food recovery. We will be evaluating each jurisdiction over the next 4 years, assessing their compliance with the requirements, and utilizing a progressive enforcement process, using penalties only as a last resort until, all other compliance actions have failed. Last slide. That's the end of my presentation. I did include 2 additional slides at the end that you all have access to provide more of an overview of the infrastructure and edible food recovery grants programs. Thank you so much for your time, and to each of you for commitment to dealing with climate change. Thanks so much.
Thank you, Kara. Very complicated relationship between the state and local government on this, and really interesting to hear how you're dealing with it. We're gonna switch gears here and hear more about the China experience. So let me turn it over to Dr. Liu. You're on mute.
Thanks. So it's so honored for me today to join the discussion, and also quite impressive report about the California lesson learned and how to reduce the thing from waste sector. From my side, I will try to first share some of my experiences or our project experiences in China, and then also I will have some questions, maybe really curious about what is the lesson learned further based on the report, and maybe can be further exchange with China's experiences. So can you see my slides?
Yes.
Okay. For JLA China, we have a project called Integrated Waste Management LAMA project, launched in the year of 2007. And it's really quite interesting because we're focusing on the greenhouse gas emission in waste sector, and we have 5 demo cities in China. So currently we have some very interesting results. Maybe we can further share with you. So first I will come to some of the basic background in China. So we can see that during the past 30 years that we really has been developing a lot on the infrastructure on waste management in China. So actually in the year of 2020, we can see that for the city and county level, more than nearly 100% of the waste has been collected and environment soundly treated. But here I want to mention that actually in this number, we don't involve recycling, because for the recycling, it is not involved in the traditional waste management sector in China. It belongs to the commercial department. So normally when we're talking about waste management, we actually go directly to the treatment. So that's the reason why sometimes we will see a very huge gap between the recycling rate between China and also of the Western countries, or compare with America. But this is also some of the further tasks will maybe in future can be solved or developed them leading by the waste segregation. And we have to say that for the past 30 years, China has been really developing a lot on the infrastructure. And we just do some basic calculation that for the past 10 years, actually, the total investment in the waste treatment has been more than 350 billion RMB. So which means that it's really provide the basis for the further development of the waste management. And in the year of the 2019, China has been issued the mandatory waste segregation in 46 key cities. So we all say that the mandatory waste segregation actually is the turning point from in China, which we really turning from the waste treatment to the integrated waste management period. So here you can see some basic facilities in China about landfills and incinerations. So that's really has been changing a lot during the past years. So actually for our project, we're starting from the 2017 and we have the support from the Ministry of the Housing and Urban Rural Development, which is also leading the waste sector in China. And we have our Chinese implementation partner, which is China Association of the Urban Environment Sanitation. And we have 5 demo cities I mentioned just now. You can see quite diversity. And also we have Suzhou as our pilot cities. Currently, actually, I'm also in Suzhou for our site visits. So for our key components, we have 5 different targets, including the TA support, the policy advisory. But I want to emphasize that the key part is the greenhouse gas mitigation effect analysis. And we have this MRV system developed, and also we establish baseline, and we do every year twice to do the monitoring of what has been happened for these 5 cities and what is the influence on the greenhouse gas emission reductions. So here you can see that we identify about 15 key points here as our project boundary. And I have to say that recycling was not included. It's really a pity. And in future, we hope for the next phase, if we have some more opportunities, we can further develop on this part. So then I will give some key conclusions about the greenhouse gas emission reduction. We can see that compared to the baseline, our 5 demo cities has already achieved a very high greenhouse gas emission reduction, and we can see some more than 5 million tons CO2 equivalence emission. And also one very important part is that we can see the whole, like the greenhouse gas emission density has been decreased from the 0.8 to 0.3 ton CO2 per ton municipal solid waste. So we can see that continuously low carbon transition of the municipal solid waste sector in China is really can be identified from our project. And we have to say that more than 80% of them are the prevention of the methane emissions. So here are some further information of where are this kind of the reduction has been achieved. So the first one is we can see that the incineration plants is really being developed a lot in China for the past 20 years. So we do not argue a lot about the plastic issue. So it's just another one beside the methane, but only if we really want to identify the methane reduction, we have to say that the prevent of the mixed waste go to the landfill is really contribute a lot, and it's contribute about more than 80% for the past transition period in China. But currently, with the further waste segregation has been promoted in China, we can see that more and more the food waste treatment or the organic waste treatment plants has been contributed more. We can see about more than 17% was increasingly and contributed by the organic waste treatment plants. And because we don't include the recycling part, so we couldn't identify or we couldn't give a very detailed information about how much has been contributed for the recycling. But actually we can see from the cities that with the further promotion of the segregation, if we can achieve a very good recycling rate from the cities, and also with the further promotion and the integration from the formal sector and the informal sector, we can see that this kind of the promotion of the recycling of the plastic, especially the low value plastic, will be further improved and will be maybe the second phase of the greenhouse gas emission reduction in China. So it will be very interesting if we can have this following research on that. So we also see that there are some challenges for the incineration plants, because with the further segregation of the organic waste, for the incineration plants, they will face the challenges that their greenhouse gas emission amount may be increased, because the organic part has been diverted, and the plastic or the fossil part will be increasing, especially when we have this kind of the economic development. And also we can see that this kind of the plastic content has been increased for the past 5 years. So the further promote of the resegregation will be the second phase of the key focus for the resegregation in China, and also to promote the energy recovery efficiency, and also to utilization of the heat will be the key focus. And for the food waste management, to reduce the leakage and to further promote the digested utilization will be very important. And then for the landfills, actually still will be one of the focus, but because for more than 50% of the cities in China, maybe they already achieved that the zero landfill for the mixed waste. So actually that's also be maybe the management of the landfill gas, and also the closer project of the landfills should be the key focuses. And then I also agree with the report just mentioned about the data part, because I think the better data collection will be very important. And also in our project, we can see that we still lack of some part of the data, which makes that we only need to compromise to make some assumptions and to choose some parameters to make the whole model can be worked. But we still need some further improvements on the whole data collection systems. So that's some of the summary of basic information from our project, and also really looking forward to the further exchange. And also from my side, I'm really very curious about the report mentioned just now. And I also think that because you mentioned that in America, for the compost part, the market has been very mature and will not be the challenge. But I have to say that maybe in China, when we're talking about organic waste treatment, one of the key challenges should be how to really make the compost or digested can go to the market. Although we have the standard, but we still think that the market is not so mature, and we really need to further optimize, and we can really try to find a way to deal with the compost. Also, I think maybe in the next stage, the Professor Zhang Xuehua, and you can share more information about this part, but I have to say that that should be one of the key challenges in China for the organic waste treatment. So that's from my side. Thank you.
Thank you, Dr. Liu. I have a quick question for you, if I may. I saw in your slides that a significant percentage of the waste is incinerated. And I wonder if you are able to control air emissions from the incineration, or if that's an issue that's arisen.
I have to say that currently, if you come to China, you can see that all of the incineration plants, they pay more than 50% of their invest are focusing on the gas, the air pollution control. And also in China, the incineration plants, they really have even more strict standard rather than Europe. So it's really a lot of the efforts has been doing for controlled air pollution.
Thank you for that. And we hopefully get to some of your compost question in a minute as well. All right, our last panel speaker is Dr. Zhang.
Thank you for inviting me for this talk. I really enjoyed reading the report and then learned a lot recently about, oh, I'm sorry, I should speak Chinese, sorry, because my whole talk is about Chinese, I'm so sorry. 我首先很感谢大家邀请我来参与这个研讨会。我也读了很多关于那个加州甲烷消减的报告。这中间提了一个非常重要的，也是目前有机废弃物资源化利用的一个路径呢，实际上是堆肥。因为我所有的研究呢，这个项目呢都是在中国完成的，所以我今天呢就用中文来讲。 讲社区堆肥在中国的研究与实践。这个堆肥呢，实际上大家可能都知道，它就是一个人工控制的生物化学过程，是利用微生物的分解作用，将有机废弃物呢转化成稳定的腐殖质。这里面有一个很重要的，前面可能都没有提到的，它不仅能够改良土壤，然后呢就带来食品安全，解决食品安全问题。其实堆肥产生的堆肥产物，因为它富含有机质，尤其是富含有机碳，还有呢就是富含微生物，所以它施用到土壤以后，实际上能够起到碳汇的价值。我们今天讲的社区堆肥呢，本质上就是一种堆肥，但是发生在社区，是一个公共的区域，而它主要的特点呢，就是它的原料都是本地化，就近进行堆肥，产物呢就地使用，改良城市土壤然后也是带来一种生态种植。它除了能够减少有机废弃物填埋所带来的温室气体排放，但同时呢，它施用以后也有一定的固碳效应。社区堆肥因为在社区发生，有居民参与、社区共建，所以它也有很重要的一个宣传教育功能，还有就是社区共建的功能。我们这个项目呢是万科公益基金会发起的，支持的。然后我们是在2019年开始第一期项目，2021年到2022年是第二期项目。这项目其实主要解决2个问题。第一个呢，就是在全球范围内，社区堆肥都在兴起。那么，社区厨余堆肥在中国究竟具不具有可行性？这个可行性非常简单，就是整个堆肥过程的管理要基本做到异味少、蚊虫少，基本没有渗滤液，居民能够接受。那么第二期呢，在第一期的基础上，我们也就想尝试社区堆肥能不能够像印度、西班牙，包括现在美国，它能不能成为有机废弃物在中国在地资源化利用的一条技术路径。所以这是第二期我们想解决。第二期呢，目前基本完成，我们在考虑第3期项目了。那么这个作为技术路径，在社区堆肥和堆肥的基础上，我们进一步明确，它呢是集中式堆肥的一个有益的补充，然后呢是一个耗氧的自然的堆肥过程。这里面呢，厨余每天产生有机废弃物，每天产生，那么它就存在一个连续添加。堆肥过程基本不耗能或者耗能非常低，我们就是以人工代替了机械和耗能。这就是 IPCC 讲的，为什么堆肥过程管理得当，可以说它没有温室气体排放，给这个人工代理机械和能耗能是有很大关系的。然后整个堆肥过程呢，要基本做到安全无害化，堆肥产物经过检测能够达标，然后能够实现就地分级使用。这2期实践从2019年到目前为止，这个呢就是我们所有的试点机构在全国分布的状况。一共呢有2期，然后第3期我们刚刚开放了社区厨余堆肥平台，目前在10几个省、20几个市，一共有30多个点。有乡村的居民社区，也有城市居民社区，有中小学校园，也有办公小区。办公园，然后这就是整个给大家一点概念哈，这种在中国做社区堆肥，这些社区是什么样子？就是中高层的居民小区、乡村，还有大学。我们说的堆肥原料哈，这里面非常明确，社区堆肥以厨余为主，尤其是分类以后形成的纯度比较高，基本没有被污染的我们称为高氮物质含氮量比较高的，就是厨余新鲜捡下来的园林绿化垃圾纯度比较高，你可以看到，因为这个大部分是居民分或者是保洁员2次分拣形成的，所以厨余的纯度非常重要，它直接决定了堆肥产物的品质，这是我们非常关心的。那么就堆肥原料，另外一个除了高氮物质就是高碳，作为一个调节物质，这种呢，我们这里面有园林绿化垃圾，有破碎的树枝、落叶、秸秆，这些都有。所以我们这3年的试点下来，是各种各样的当地的因地制宜采取的调节物质都使用过。这中间还有个比较重要的，就是前期的堆肥产物，因为它富含微生物和有机质，所以它作为一个覆盖物的话，有效减少堆肥过程的甲烷气体的排放。 堆肥设施呢，你看到开放式的百花齐放，因地就宜。这里面有相对密封的，就是木质的，树木的，还有就是开放式的，就是说透气性非常好的空心砖制作的，还有金属网制作的，还有就是竹编的堆肥设施。有些呢是统一制作的，但很多呢就是各个社区自己设计、自己创造的。整个堆肥的过程呢有很多种方式，因为我们几十个社区嘛，但是总的来用一个比较经典的动作呢，过程就是流程是厨余有个分类，它就收集，然后社区类转运，转运以后在堆肥之前有一个20分拣，确保它的纯度，然后厨余呢有部分的破碎。然后我们通常采用3明治方法，这个是最节省体力的，就是1层厨余1层调节物质，但也有混合以后进行添加的。一般在每次堆肥每天完成之后，我们都会用调节物质，有树枝落叶，但也可以用成熟肥进行覆盖。这个覆盖就是减少蚊虫然后就是异味，更重要的是减少堆肥过程中的甲烷气体排放。整个堆肥呢50到70天完成，中间也涉及翻堆，最后堆肥产物有个筛选过程。这第2期的，我们第1期呢，今天我都没有讲了，主要就是时间限制，我讲一下第2期，因为第2期呢，我们从大概10个月执行下来，有150吨那样子的厨余堆肥周期呢，最短的50天就能完成，最高呢高达90天，大部分都没有添加菌剂，这里面原料的配比非常重要，就是我们说的厨余和调节物质、高氮的物质，它这个配比，我们一般是体积比1:5比1和或者4比1的比例，你可以看到园林绿化垃圾占比比较高。我们刚才已经讲了，就是说第2期要作为一个技术路径的探索，那么它的堆肥连续性非常重要，因为厨余在社区里每天产生，你每天都要进行堆肥。这里面我们第2期10个点呢，实际能够实现连续堆肥的只有2个点，就是每天都有，而且有些点高达100公斤以上。这样子处理下来，它1年的话能够有30多吨的厨余量，所以大部分还是很难做到，因为挑战非常大，就是连续堆肥。堆肥过程管理的一个非常重要的指标就是温度。如果堆体我们所有的点都实现了堆体能够达到55度以上，持续5天，这个呢就有效的灭掉病原体，还有杂草种子。还有一个非常重要的，就说明整个堆肥过程它的透气性比较好，堆体的结构比较好，那么这里面有效的避免了各种温室气体的产生，就一氧化二氮和甲烷。所以温度曲线这种比较标准的教科书式的温度曲线，基本上决定了堆肥产物的品质非常好。然后堆肥产物呢，我们这2期做下来，检测了将近160个、154个样品，其中呢105个都是堆肥产物。所以中国做了这么多年堆肥，很多人都质疑这个堆肥产物关于盐分重金属超标，我们有意识的连续3到4年就对这些产品进行连续的监测。然后这里面给大家看一下，它这个我们也建立了一套指标体系，一共有20个指标，除了物理指标以外，还有5个重金属指标，包括那个分大肠菌群，就是这个安全无害化非常重要的指标，还有它的腐熟度。堆肥要作为一个成熟的产物，适用于土壤，不能危害作物的生长。那么实际上它这个它的腐熟度非常重要，这种子发芽指数，然后就是养分指标，氮磷钾。这里面呢，我们目前总的来说，所有的样品基本上没有出现重金属超标。个别样品的那个有效活那个发芽指数没有达标，但绝大部分都腐熟。这里面总养分能够达到有机肥标准的可能1半，大部分呢是做不到商业有机肥的标准，但是作为农家肥的这种有机肥标准，它的质量是很高的。最后给大家看一下，就堆肥产物我们在各个地方试点机构使用的一个非常明确的对比。第1期的时候，万科公益基金会就是万科公司支持的，而万科公司的总部呢，实际上我们是我们一个堆肥点，他们主要是用食堂的厨余混合园林绿化垃圾进行堆肥。你可以看到它这个园区的绿地这个差别非常大，就是说有机肥施用之前和施用之后非常大。 就是说这也是各个小区都愿意尝试的非常重要的一个因素。所以呢，总结一下哈，就是我们做的这3年的社区厨余堆肥，它实际上非常重要的就是实现了整个堆肥过程能够被居民所接受，基本上没有渗滤液，蚊虫比较少异味也比较小，而这几个非常直观的指标和它最终就是我们整个堆肥过程温室气的管理其实是一致的，能够做到这几点，堆肥过程的这个它的温室气体排放基本上都可以当作零目前我们下一步要想做就可以做实地检测准备下一期也尝试监测整个堆肥工程，进行动态监测它的温室气体排放。但是从目前文献来看的话如果它的湿度堆体湿度能够在50%以下，然后呢整个过程就刚刚我们说到那几个指标能够达到，温度能达到55度，持续5天以上，这个过程堆肥产物的品质能够达标同时呢能够做到安全无害还田，还有一个非常重要的就是它的整个的过程温室气体排放基本上能够忽略不计。我今天就分享到这儿，我知道有很多问题，希望给大家共同探讨有关堆肥呀，还有这个有机废弃物它的那个处理的方面。谢谢大家。
Thank you so much, Dr. Shang. We can talk about compost in California forever. And I'll put in a quick plug. UC Berkeley has done some pretty interesting work on showing that compost added to soil increases carbon sequestration in the soil. So there's additional benefits as well. And I note that there are some questions in the Q&A, and I see that some of the speakers are responding in writing, which is great because sadly, as often happens, we run out of time and really need to wrap up, I'm afraid. So if you want to send some more Q&A around as we do the closing comments, that would be great. And we can have some of the speakers respond as well in writing would be helpful as well. But because we're just about out of time, I need to switch gears and turn it over for some closing remarks to Mian Chen.
Oh, thank you, Ken. It is my honor and pleasure to give some closing remarks. And thank you to our speakers for this productive discussion. I have also learned a lot from today's conversation. Here are some of my takeaways. In addition to energy and agricultural sectors, we saw like solid waste actually is the third largest source of methane emissions. And also both US and China actually are taking actions to reduce solid waste methane. From the report presented by Xing, we have learned about California's experience in reducing methane emissions in the solid waste sector, especially its main strategies in reduce organic waste and also to reduce methane from existing landfills. And Matthew and also Kara discussed a lot of like policy implementations in more details, especially in policies for organic waste reduction. And to facilitate policy implementation, we saw like California actually developed a specific local program requirements and also provide local assistance grants and strong compliance mechanisms. And Dr. Liu and Dr. Zhang also provide great introduction to solid waste methane reduction in China. And Dr. Liu actually discussed integrated waste management NAMA programs, which actually has made lots of progress in methane reduction in China. But because waste recycling is managed by another government agency, so actually currently waste treatment focuses more on waste incineration and landfill at this point. And Dr. Zhang actually discussed organic waste reduction with a focus on a community-based composting in China. But we saw actually currently the key challenge for composting in China is how to put the composting into the market. So hopefully we are going to have like more discussion in that part. And going forward, hopefully to see more US-China collaboration in experience sharing in this field. As discussed today, we actually saw methane reduction is still facing challenges in terms of infrastructural capacity emissions data and policy and financial support. So we look forward to continuing this discussion in the near future. Thank you.
Thank you very much. We are anticipating, hopefully soon, a methane action policy from China to be released. And so I think this is much the beginning of the conversation. And I can say from California's perspective, we very much look forward to working on different possibilities, pilots and projects between California and China, and we think there are quite a lot of possibilities. The discussion has been recorded, as I noted, and it will be available on the California-China Climate Institute website and YouTube channel. So with that, I want to thank the audience, and I want to thank our superb panelists for an excellent discussion, and wish you all a very good day and a very good evening. Thank you very, very much.